Hello and welcome to Classroom Teaching. In this session, we are going to start a very new chapter, that is nothing but measurement of matter. Students, in last session or in last few years, that means in 8th standard, in 7th standard, we learned about the structure of atom. We have seen the theories of Dalton, Thomson and Rutherford. According to Dalton's theory, we have learned that the compound is formed by the chemical combination of the atoms of different elements. That means whenever the atoms of different elements they join, the molecule of compound is formed. And various scientists, they studied the structure of compound. In 18th and 19th century, Dalton, Thomson and Rutherford, mainly Dalton's atomic theory, contributes in finding the molecular formula of the compound. Various scientists they studied, they make research, and finally, according to the Dalton's theory, the compound or the molecule of a compound is formed by the chemical combination of various atoms of different elements. And they verify the law of chemical combinations. So actually, the law of chemical combinations, it is based on Dalton's atomic theory. We can prove, or various scientists they find out the molecular formulae of various unknown compounds by using the Dalton's atomic theory or by using the law of chemical combination. Here we are going to prove the law of chemical combination by using known compounds. Molecular formulae of the known compounds we are taking, and we try to prove the law of chemical combination. So this is our first article that we are going to see in this video, the law of chemical combination. Laws of chemical combinations, because there is not only one law but various laws. In this standard we are going to see two laws of chemical combinations, that is nothing but law of conservation of matter and the second is law of constant proportion. Both these laws they are included in laws of chemical combination. Clear cut meaning is there. While chemical combination is there, the reactants and products they follow certain rules, they follow certain laws. You can see the diagram here and say what we are taking. We are taking in a conical flask, we are taking calcium chloride. The solution of calcium chloride we have taken. In a test tube, the sodium sulfate solution is taken. Then tie a thread to that test tube and insert that test tube slowly into the conical flask. Then tight a cork rubber cork over the conical flask and weigh that conical flask. Take weight of that conical flask. That means the weight of that conical flask, it includes the weight of conical flask, the weight of calcium chloride, and the weight of sodium sulfate and weight of test tube also. So the entire assembly, the weight of entire assembly is taken. Then tilt that conical flask or shake it slightly so that all the sodium sulfate solution it pour into the calcium chloride. What happened? Definitely the chemical reaction is taking place. Let us try to write the chemical reaction. Calcium chloride, that is nothing but CaCl2 plus sodium sulfate, that is nothing but Na2SO4 what should be formed? Here calcium sulfate and sodium chloride are formed. That means this calcium, it reacts with or it combines with sulfate group. So CaSO4 calcium sulfate plus sodium chloride, that means twice NaCl. So these are nothing but reactants and these are the products. Now in the conical flask, calcium sulfate and sodium chloride is present. That means after reaction, chemical combination, chemical change take place there. Then weigh again the entire assembly, because the cork is present there, therefore nothing is going out of the conical flask, and therefore weigh it again and you can find that it has the same weight as the reactants. So this is nothing but the law of conservation of matter. So this law is called as law of conservation of matter. Law of conservation of matter, that means the total matter it get conserved. That means the total weight of reactants and the total weight of product, it must be equal. That means it get conserved. That means whenever the chemical combination takes place, the total mass of the reactant and the total mass of the product, it is always same, or it get conserved, or it doesn't change. So this is nothing but law of conservation of matter. The second law that we are going to see, it is nothing but law of constant proportion. The second is law of constant proportion. The first law, it is very easy, it is clear. Law of conservation of matter means whenever a chemical reaction is taking place, the weight of reactant, and total weight of reactant and the total weight of product, it always remains changed. It remains unchanged. The second is law of conservation, constant proportion. We know whenever the compound is formed, whenever the molecule of a compound is formed, let us take an example of H2O. H2O, that means hydrogen and oxygen, they combine together to form a molecule of H2O. So irrespective to the source of water, the proportion by weight of the constituent of any compound it must be constant. What is the meaning of that? The proportion by weight of constituent elements. Now the constituent elements are hydrogen and oxygen here. So irrespective to the source, the proportion of hydrogen and oxygen in H2O, it must be constant. That is nothing but law of constant proportion. The proportion must be constant. Here it is 1:8 proportion. That means if we take the water from well, if we take the water from river, or if we take the water from any source, the proportion of hydrogen and oxygen in that water molecule, it is always 1:8 by weight. That means if we take 9 grams of water, then in that 9 grams, 1 gram it is of hydrogen and 8 grams it is of oxygen. So this is nothing but law of constant proportion. Actually in 1794, J.L. Proust, he stated this law of constant proportion. Take one more example which is given in the textbook. Take the example of carbon dioxide, CO2. Here the proportion of carbon and oxygen, that means the proportion of the constituent elements which are present in this compound, the proportion by weight, it is constant and it is 3:8. 3:8 proportion. That means if we take 44 grams of carbon dioxide, then 12 grams of carbon and 32 grams of oxygen are present in it, irrespective to the source of the matter. What is the meaning of that? Again, the carbon dioxide we exhale. While respiration process, we exhale carbon dioxide. So if we take that carbon dioxide, secondly, if we take the carbon dioxide which is formed if we burn carbon, that means C plus O2 gives CO2. If we take that carbon dioxide also, or if we take carbon dioxide which is present in atmosphere, we know carbon dioxide is present in air in a proportion of 0.033. So if we take that carbon dioxide, that means we are taking carbon dioxide from 3 sources, and if we check the proportion of carbon and oxygen in each case, then each time we get that the proportion should be 3:8. Carbon 3, oxygen 8. So this is nothing but the law of constant proportion. That means if irrespective to the source of the compound, the proportion by weight of the constituent elements which are present in that compound or in that molecule, that proportion should be constant. This is called as law of constant proportion. The proportion by weight of constituent element in various examples, in various samples of compound is fixed. So this is nothing but law of constant proportion. So the laws of chemical combination, it has 2 laws. First is law of conservation of matter. In 1785, French scientist Antoine Lavoisier, he gave this law. Then the second law that we have seen, law of constant proportion. In 1794, J.L. Proust stated this law of constant proportion. In both these laws, in law of constant conservation of matter, the total weight of reactant and the total weight of product after chemical reaction, it get conserved, that means it remains constant. The law of constant proportion, in which the proportion by weight of constituent elements of various samples, they are fixed. So these are nothing but about chemical combination, laws of chemical combination. So here we stop for this video. Thank you very much.